Venus. We see it as the brilliant star of morning and evening, a glowing jewel suspended in the night sky. For thousands of years, people have watched its steady light and wondered what lies beneath those golden clouds. Ancient civilizations saw it as a world of beauty, a celestial twin to our own Earth, filled with promise. But today, we know the truth. Behind that mesmerizing beauty lies one of the most hostile worlds in our solar system, a planet of extremes, both strangely familiar and terrifyingly alien. Let's journey to this world and uncover the secrets hidden beneath its veil. Venus orbits the Sun about 108 million kilometers away, making it our closest planetary neighbor. It's almost the same size as Earth, which is why it's often called our sister planet. Its path around the Sun is nearly a perfect circle, so its distance from the Sun barely changes. When it swings by our planet, it comes as close as 41 million kilometers, the closest any planet ever gets to us. But even then, we can't see its surface. Its thick, reflective clouds hide everything, revealing only a dazzling crescent in the sky. This crescent is why Venus shines so brightly. It reflects so much sunlight that it becomes the second brightest object in the night sky, outshone only by the moon. One of the most peculiar things about Venus is its rotation. It spins backward compared to most other planets from east to west, and it does so incredibly slowly. One full rotation takes 243 Earth days, which is longer than its year of 225 Earth days. A single day on Venus, from one sunrise to the next, lasts a staggering 117 Earth days. Imagine a day that lasts for months. This slow spin, combined with its incredibly dense atmosphere, creates powerful waves that whip around the entire planet in just 4 Earth days, a phenomenon known as superrotation. The atmosphere literally moves faster than the planet itself spins. For centuries, Venus remained a complete mystery. Through our telescopes, all we could see were those impenetrable, swirling clouds. No one had any idea what was waiting below. That all changed with the dawn of the space age. But the few that succeeded changed our understanding of the solar system forever. The Soviet Union's Venera program was particularly groundbreaking. The Venera 4 probe became the first spacecraft to enter the atmosphere of another planet and send back data. Then, in 1970, Venera 7 made history. It became the first probe to successfully land on another world and transmit information back to Earth. As the Venera landers descended, they painted a picture of a truly hellish world. At about 60 kilometers above the surface, they entered a thick, suffocating layer of sulfuric acid clouds that stretched for miles. These clouds are so dense, they block almost all sunlight. Only about 10% ever reaches the ground. The sky there isn't blue, but a dim, oppressive orange. Hurricane-force winds tear through the upper atmosphere, and scientists believe powerful lightning flashes occasionally illuminate the hazy gloom. As the probes continued their descent, the conditions became even more extreme. The atmospheric pressure and temperature climbed rapidly. Near the surface, the heat soared to a scorching 464 degrees Celsius, or 867 degrees Fahrenheit, hot enough to melt lead. The pressure was even more crushing, reaching over 90 times that of Earth's at sea level. It's the equivalent of being nearly a kilometer deep in our ocean. Yet, amidst all this hostility, there was something familiar. The gravity on Venus is only slightly weaker than our own. If you could somehow stand on its surface, you would feel almost the same weight as you do on Earth. But what would you see? Since we can't see through the clouds with normal cameras, scientists have used radar and infrared instruments to map the hidden landscape. What they've revealed is a world sculpted by fire and pressure. The surface of Venus is covered in vast, rolling plains, towering volcanoes, and strangely deformed mountains. Craters from asteroid impacts are surprisingly rare. This is because the thick atmosphere acts like a shield, burning up most smaller meteors before they can even reach the ground. In the early 1990s, NASA's Magellan spacecraft used powerful radar to map almost the entire planet, giving us our most detailed look yet. The maps showed that Venus has been completely reshaped by intense and widespread volcanic activity. Its surface is geologically young, estimated to be only about 300 to 500 million years old. Volcanoes absolutely dominate the scenery. Massive shield volcanoes like Mont Mongs rise higher than Mount Everest, surrounded by vast plains of solidified lava. There are also strange, circular features called pancake domes, which are thought to have formed from thick, slow-moving lava oozing out onto the surface. Some volcanic regions stretch for hundreds of kilometers, hinting at colossal eruptions that must have occurred in the planet's past. And the most exciting part? Evidence from recent missions suggests that some of these volcanoes might still be active today, spewing lava and gas into the thick atmosphere. Unlike Earth, Venus doesn't have plate tectonics. Our planet's crust is broken into moving plates that shift, collide, and create mountains and earthquakes. Venus, on the other hand, seems to have a single, solid crustal shell. Scientists believe that heat builds up beneath this rigid surface over millions of years. Eventually, the pressure becomes too much, and the heat bursts through in massive, planet-wide resurfacing events, melting and reshaping the landscape. We see evidence of this in huge circular patterns called coronae. These are regions, hundreds of kilometers wide, where hot material from the mantle pushed the crust upward before collapsing. There are also ancient, rugged highlands called tesserae, whose fractured, tile-like patterns show signs of immense geological stress from a chaotic past. The atmosphere above this fiery landscape is one of the most complex and dynamic in the solar system. At the planet's poles, there are massive, swirling whirlpools of gas known as polar vortices. These giant storms constantly twist and change shape, sometimes in a matter of hours. In the upper cloud layers, spacecraft like Japan's Akatsuki have used ultraviolet and infrared cameras to reveal mysterious dark streaks, being whipped around by the super-rotating winds. Scientists still don't know what these dark patches are made of. The chemistry of the clouds continues to surprise us. In 2020, a team of scientists announced the potential detection of phosphine gas in the Venusian atmosphere. On Earth, phosphine is a molecule often associated with biological activity. The news ignited a firestorm of speculation and excitement. Could there be some form of microbial life floating high in the clouds of Venus, where the temperature and pressure are much more Earth-like? While later studies have questioned the initial findings, the possibility, however remote, has reignited our curiosity about this enigmatic world. From a beautiful star in our night sky to a volcanic world with a runaway greenhouse effect, Venus serves as a powerful cautionary tale. It shows us what can happen to a planet so similar to our own when its climate spirals out of control. It remains a world of mystery, a place of extreme beauty and extreme danger. As we continue to send new missions to probe its secrets, we're not just learning about another planet. We're also learning more about our own precious place in the cosmos. Beneath the thick, swirling clouds of sulfuric acid, a world of fire and pressure awaits. This is Venus, Earth's so-called twin, but a twin forged in a vastly different crucible. While we often imagine its surface as a featureless, hellish landscape, the reality is far more complex and dramatic. It's a world sculpted not by water or wind, but by immense, planet-shaking forces from within. Today, we journey to this hidden realm to uncover the secrets of its volcanoes and tectonics, a story written in molten rock and fractured crust. Venus is a volcanic world, through and through. Nearly 85% of its surface is covered in ancient lava flows and colossal volcanic structures. But these aren't the volcanoes you might imagine. Let's start with the pancake domes. Picture this, vast, circular mounds, some stretching over 50 kilometers wide, but less than a kilometer high. They look like giant, flattened pancakes dropped onto the plains. These are formed by extremely thick, viscous lava that oozes out and cools rapidly, barely spreading before it hardens. It's a type of eruption completely alien to Earth, where our lava is typically more fluid. Scattered among these strange domes are the true giants of Venus, the shield volcanoes. One of the most famous, Magellan, towers nearly 8 kilometers high, a rival to our own Mount Everest. These behemoths are built up over eons by repeated eruptions of much runnier lava, which flows for great distances, creating broad, gently sloping shields. But what's truly bizarre is how they form. Here on Earth, volcanoes often line up along the edges of our shifting tectonic plates. Venus doesn't have that. Instead, it has what scientists call a stagnant lid crust. The entire outer shell is one solid piece. So, these massive volcanoes are born when plumes of hot rock from deep within the mantle punch their way through the crust at seemingly random spots. This single, unbroken crust leads to other unique geological features. Instead of plates grinding against each other, the immense internal pressure just pushes, pulls, and warps the surface. This creates incredible formations called coronae. Imagine a giant bubble of hot mantle material rising and pushing the crust upwards. As it cools and the magma recedes, the center collapses, leaving behind a circular, crown-like structure, often surrounded by concentric ridges and fractures. These coronae can be enormous, some stretching 1,000 kilometers across, acting like windows into the planet's fiery interior. Then there are the tesserae. Found in the highland regions, these are some of the oldest and most mysterious terrains on Venus. The word means tile in Greek, and that's exactly what they look like from orbit. A complex, chaotic mosaic of intersecting ridges and valleys. This terrain has been pushed, pulled, and twisted in every direction, a testament to a long and violent geological history. Scientists believe the tesserae might even be an ancient form of continental crust, perhaps a relic from a time when Venus was a more Earth-like world. The sheer pressure of Venus's atmosphere, over 90 times that of Earth's, also plays a crucial role. It acts like a pressure cooker, keeping erupting lava molten for much longer. This allows flows to travel for hundreds of kilometers, creating the vast, smooth plains that dominate the planet. Radar images from the Magellan spacecraft in the 1990s revealed these flows in stunning detail, showing a landscape of overlapping lava fields, winding channels, and intricate fracture patterns, a frozen record of countless eruptions. All of this begs a huge question. Is Venus still geologically active today? The evidence is mounting. Subtle changes in radar data over the years suggest new lava flows have appeared. In fact, a reanalysis of Magellan data confirmed that that Everest-sized volcano likely erupted in the early 1990s. Venus is not a dead world. Its heart is still beating, its interior still restless, shaping the surface with fire and pressure. Studying Venus isn't just about understanding another planet. It's about understanding our own. It serves as a planetary laboratory, showing us what can happen to a rocky world under extreme conditions. It helps us understand the fine line between a habitable planet like Earth and a runaway greenhouse inferno like Venus. For decades, Venus has guarded its secrets jealously, its thick clouds forming an impenetrable veil. But a new era of exploration is dawning. NASA is launching 2 ambitious missions that promise to revolutionize our understanding of our sister planet. First is VERITAS. This orbiter will use state-of-the-art radar to map the surface in unprecedented detail, capable of detecting changes in the landscape just a few meters high. It will search for active volcanoes, measure the heat radiating from the surface, and reveal the true nature of those mysterious tesserae regions. VERITAS will finally tell us if Venus's volcanic heart is still beating strong. Following close behind is the DAVINCI Plus mission, which will take a much more daring approach. It will drop a probe directly into the thick, crushing atmosphere. During its hour-long descent, it will taste the air, measuring its composition, temperature, and pressure all the way down. It will search for chemical clues, like the fingerprints of ancient water, that could tell us if Venus once had oceans. As it nears the surface, it will even take the first-ever high-resolution images of the ancient, tiled terrain of a tessera region. Together, these missions will peel back the layers of mystery that have shrouded Venus for so long. They will give us a new perspective on how a world so similar to our own could have ended up so different. NASA isn't going it alone. The European Space Agency's Envision mission, launching in the early 2030s, will work alongside VERITAS. It's bringing higher-resolution radar to peer even deeper beneath the planet's crust. Russia, a historic pioneer in Venus exploration, is planning Venera D, a lander and orbiter designed to survive on the brutal surface longer than any mission before it. India's Chandrayaan-1 will study the upper atmosphere and its dance with the solar wind, while China is exploring a concept to send multiple small probes into different atmospheric layers. Imagine it, a global network of observation, a fleet of robotic explorers all focused on one world. Together, they will transform Venus from a distant, shimmering mystery into a comprehensively studied planet, a world we can finally begin to understand. But perhaps the most tantalizing goal of this new era isn't about rocks or volcanoes. It's the search for life, not on the scorching, molten surface, but high above it. At altitudes between 50 and 60 kilometers, something incredible happens. The temperature and pressure become surprisingly Earth-like, hovering around a comfortable 30 degrees Celsius and 1 atmosphere of pressure. Here, in this perpetual twilight zone, droplets of sulfuric acid and strange aerosols drift through the thick clouds. This is where the story gets really interesting. Some scientists believe that if life ever existed on Venus billions of years ago, back when it was cooler and wetter, it might have migrated upwards as the surface became a living hell. These hardy microbes could have retreated to the clouds, making a home in the only habitable zone left. This idea exploded into the headlines in 2020 with the controversial detection of phosphine gas. Here on Earth, phosphine is almost exclusively produced by microbial life or industrial processes. While it can form through other exotic chemistry, the possibility that it came from life on Venus was electrifying. Follow-up studies have questioned that initial finding, but the spark was lit. It reignited a debate that had been smoldering for decades. Future probes like Rocket Lab's Venus Life Finder and the DAVINCI descent capsule are designed to settle this question. They will dive directly into the atmosphere, sniffing for phosphine, ammonia, and the complex carbon molecules that are the building blocks of life as we know it. They are, in essence, galactic bloodhounds on the trail of alien biology. Even if they find nothing, the mission is far from a failure. A negative result would still teach us invaluable lessons about how chemistry behaves in such an extreme, sulfuric environment. It helps us define the very boundaries of where life can and cannot exist. But imagine if they do find something. A hint of biological activity, a molecule that shouldn't be there, a single microscopic cell. It would be one of the most profound discoveries in human history. It would fundamentally redefine our place in the universe and our understanding of what it means to be alive. Even if Venus proves to be sterile, her story remains one of the most vital in the solar system. She is a stark reminder of how a planet so similar to our own can take a dramatically different path in its evolution. As our technology advances and our curiosity deepens, we are standing on the very threshold of answers that have eluded us for centuries. The goddess of the dawn still shines above us, veiled in cloud and mystery, waiting patiently for the next generation of explorers to lift that curtain once more. In the end, Venus is not just another world. It's a mirror that reflects both our own planet's distant past and a chilling vision of a possible future. Once, Venus may have been a blue planet, its skies filled with clouds of water, its surface washed by ancient seas, a true sister to Earth. But somewhere along its journey, something went terribly wrong. The warmth that once might have nurtured life became a runaway fire that consumed the entire world. Its oceans boiled away, its atmosphere thickened into a crushing blanket, and its primordial beauty turned into a deadly trap. And yet, even in its ruin, there is a haunting elegance and austere grace in the golden clouds that forever hide its face. For scientists, Venus is more than just a mystery to be solved. It is a warning written in giant letters across the heavens. It reminds us that planetary balance is fragile, that climates can tip over into irreversible chaos, and that entire worlds can be lost. But it's also a testament to endurance. Despite the impossible heat, the crushing pressure, and the constant rain of acid, Venus remains a beacon in our sky. Second only to the moon in its brilliance, it has captivated humanity since the dawn of time. She is still there, whispering secrets across the void, challenging us to look closer, to understand, and to learn from her story. Every mission that dares to approach her adds another piece to the puzzle, another step toward understanding not just her fate, but our own. In her atmosphere, we study the limits of chemistry. In her rocks, we glimpse the powerful forces of geology. And in her evolution, we confront our own planetary destiny. Perhaps one day, human eyes will see her horizon not through the lens of a robotic camera, but through the visor of a helmet. Perhaps we will stand beneath a pale orange sky, witnessing her desolate beauty firsthand. Until that day, we continue to watch, to listen, and to wonder, because Venus, the eternal morning star, still burns with the promise of discovery. And as long as she shines, so too does our desire to know the universe, and in doing so, to better know ourselves. Thanks for watching.